Hello, everybody. This is Physics 2212 Lab number 3, and I'm Brandon Schmitz. So, without further ado, let's get right into it. So, what this lab is basically about is we're getting a bar magnet and getting this magnetometer app on our phone to see how magnetic fields vary with distance from the source. So basically for this lab, we have to know about magnets, magnetic fields, Earth's magnetic field, most importantly, the bios of our law to calculate the intensity of a magnetic field. So the value B is equal to the permeability constant times the number of turns and the intensity of the current divided by the radius times 2. We're going to use that later on for our final calculation, so remember that one. And we need to take out Earth's magnetic field from the y value because, well, it's like gravity. We always have to factor it in. So you have to add that plus the effect of the bar magnet to get the total effect on the phone's magnetometer. To start off the procedure, we take a bar magnet and put it on the end of a meter stick, and then take our phone and put it near, like, tangent to the meter stick with magnetometer turned on. So we slide our phone upwards perpendicular to the meter stick, and the Z value of the magnetic field doesn't change, so we ignore it. We're only interested in calculating X and Y. The Z is basically just like because of the grooves on the meter stick, so it's insignificant. So we're looking at for step 1, trying to find when absolute value of X comes to a maximum. So we're trying to calculate that position, and then it senses it on the phone, and then we take some tape and we slap it on top of that phone to mark where the maximum is. Then rotate the phone 90 degrees and we move it up along the meter stick until we see a maximum Y value. In other words, like it starts decreasing, then we move it back and then put another tape. So we got an X with the tape, and X marks the spot where we find the maximum. We'll plug those values into the equation. So the maximum X value was at 0.13 meters, aka 13 centimeters, and it was about 206 microteslas. So plug and chug the use of our law, you get net magnetic field of about 51.0 microteslas. It's crazy. It's a lot of microteslas. So let's think about some conceptual stuff. What if we hadn't oriented our experiment to compensate for magnetic north, and instead just laid out our meter stick at some intermediate angle with respect to its magnetic field? That would kind of mess it up because it would be off by like a sinusoidal function relative to north. Because when we're subtracting out Earth's magnetic field, we're assuming that it's parallel to true north. But now we have to adjust it for a mixture of X and Y components, so it basically just complicates the experiment for no reason. So if we stick two identical magnets together and run the experiment again, then I said that would amplify the magnetic field because they would their opposite ends would snap together and create a larger effect. So in conclusion, we found out how to adjust the X and Y values of a magnet and get the value and location of its maximum magnetic field. See you guys in 2 weeks for for another epic lab.